The use case I am going to present you here is based on a course given for Asset Plus and executed by Aerocampus Aquitaine. It is entitled Circuit Boards, Processor Chips, and Electronic Equipment. It targets industrial workers performing maintenance activities on robotic systems and licensed students who want to improve their skills on the various topics of robotics. The domains addressed are robotics, artificial intelligence, and autonomous systems. In this course, we have studied the following topics: embedded computer science, electronic devices such as sensors, display screens, motors, cybersecurity module, and Wi-Fi communication. The general description of this course is given in this slide. Drones rely upon electronic devices connected to an embedded computer programmed to be remotely controlled or to act autonomously. The embedded computer works with an operating system which must be installed and updated. It is also important to be able to restore it or to clone it. To connect more easily the electronic device to an embedded computer or to add functionalities, it is common to plug in a shield over the main board. Then it becomes possible to display a message on various screens to control different types of motors and to acquire sensors data. The drone is first programmed to work independently. Secondly, server applications allow a wireless communication with a remote computer by using Wi-Fi. RFID cards are often used to access to a safe location. The principle of this technology is studied through the process of reading and writing such cards. Each theoretical study is followed by a practical activity which illustrates how to concretely use each electronic device. The pedagogical approach followed in this course is given here. The course has been given online. It was composed of 7 slots of 4 hours and was ended by one exam online based on multiple choice question. The course is based on a synchronous learning. It means that each part of the course is composed of a theoretical synthesis followed by a practical activity. All the practical activities have been given online through live demonstrations. We have used instruments in this course, such as Dokeos and Microsoft Teams for video conference. The final test has been given on Dokeos platform. The teaching materials, such as PowerPoint, were accessible on the Dokeos platform. All the practical demonstrations have been given on Teams. We have used some materials to give this course, such as an embedded computer named Raspberry Pi 4. We have used a computer with a software developed by the teacher to remote control the embedded computer. We have used one robot to illustrate some application, and this one robot was named Picard Pro. We have used a Joypi kit to study electronic devices. Some electronic devices require the installation of Python libraries. All the details are given attached to the Python codes. There have been some differences between the design and the execution of this course. For example, the course was shortened to fit to the workers' availability. 7 sessions of 4 hours were given instead of 3 days and a half in a row. The course was open to licensed students, and it has been difficult for industrials to find workers available in a short period of time and in a post-COVID context where the production was restarting. Here are the drivers and the catalyst. It has been easy for the students to register online. There have been exchanges with other training centers, and many tools have been used to communicate, such as Microsoft Teams. The Asset Plus website has been used to disseminate the information. Some barriers have been encountered during this course. Few feedbacks, for example, on the content during the design phase. The top-down approach of the project did not facilitate exchange with the industrial partners. It has been difficult to find experts in the fields in training centers. It has also been difficult for industrials to find workers available in a short period of implementation. The timeline of the project was a constraint. The technical level of the participants was sometimes much higher than expected. For example, engineers assist to this course. The attendance to the course was not ideal. The availability of workers on several days was difficult. The constraints of exams have limited the availability of students. It has been difficult to make the participants exchange with the trainer, perhaps due to the English level of the students. The industry participation was constrained. Few feedbacks were accessible during the design phase and during the execution phase. As explained earlier, the COVID situation and the top-down approach and the timeline of the project did not facilitate the participation of industrial partners. We want to give a recommendation for the replication of this course. We think it is important to organize feedbacks on the design earlier. It is important to communicate with industrials to ensure availability of the workers. We think that the industrials could participate to the design of the course with the academics to be more aligned to their needs. It has been difficult to create exchange during the online courses, and pedagogy should be adapted to take it into account. It is important to maximize the attendance to the courses by anticipating the communications of the dates. We propose a minimum of attendance of 70%, and we propose also to shorten the courses to improve the availability of the workers. Thank you very much for your attention.